We continue our discourse on sampling distributions with this first example. Suppose a simple random sample of size n equals 36 is obtained from a population with mean of 18 and a standard deviation of 6. In this case, assuming that the population we're coming from has a normal distribution, then we can describe the sampling distribution of x bar. Because if the distribution originally is normal, then if the mean is 81 and the standard deviation of the parent distribution is 6, the sampling distribution of x bar will automatically also be a normal distribution, and the mean of all of your x bars will be equal to exactly the population mean of 81. However, the standard error will be the population standard deviation divided by the square root of the sample size. This will be equal to 6, since the population standard deviation is 6 divided by the square root of n. Our n, the sample size, is equal to 36. So this will be 6 divided by 6, which is equal to 1. With these parameters that define the sampling distribution of x bar, we are ready to compute probabilities connected with x bar. So for example, in question B, probability that x bar is greater than 82.55 using its normal distribution. So you have x bar, we have the mean of x bar is 81 and the standard error is 1 from what we just gathered. We can locate the number 82.5 somewhere here because it is bigger than 81, and we're interested in the region to the right, greater than, to the right of 82.5. So we go to our normal probability calculator in StatCrunch. So I'm going to go to StatCrunch, and I'll go to my statistics, go to calculators, go to the normal calculator, and I'm interested. Let me drag this up here and extend this a little bit and this a little bit too. So I'm interested in the standard calculator. My mean in this case, going back and forth, the mean is 81, the standard deviation is 1. So that was why we got those two values earlier, because we're going to need them in StatCrunch. So you have 81 and 1. So I have put in put in the parameters there. Then the next thing would be to put in greater than 82.5, 82.55. So I'll change this to greater than 82.55 and compute. And I have the size of the probability, 0.06050. So I have an answer. The size of this area is equal to 0.06, as we found earlier, 6057. With that question completed, we proceed to the next question, and that is to find probability that x bar is less than or equal to 78.5. So this will be the probability distribution of x bar. I will locate the mid value, which is 81 again, and my standard error is 1. And I would like to locate 78.5. That should be a number below 81. And I am interested in what region? The region to the left of 78.5. And the size of that region I can calculate. So I'm going to take this information to StatCrunch. So back to StatCrunch, I have the right parameters already set. I'll change this to less than or equal to, and remember, just to illustrate, 78.5. So I will change this to 78.5 and compute. So we have 0.0062. So here we have 0.0062. Done. Then, for the last part of this question, the probability that the sample mean is sandwiched between these two values. This will be equal to, looking at the distribution, I have 81 in the middle, and I will locate 80.05 somewhere here, and 82.75 somewhere here, and I'm interested in the area between them. So for this case, I will go back. I will need to alter the interface to the option of between. I already have the same values. I only need to specify the lower bound and the upper bound. My lower bound here is 80.05. I will do that. 80.05. And my upper bound from the question is 82.75. So key that in, 82.75, and hit the compute button. So I have 0.7889. So let's go back. So the size of that area is equal to 0.7889. We're done with that question. We now proceed to the next example. For the next example, we are told that a normally distributed population, which should look like this, for a normally distributed random variable x, it has a mean of 500. So the mean is 500, and a standard deviation of 60. Standard deviation is 60. Now, from this question, this should read A. Sorry for the typo there. This should be B. Yes. That must have been an auto format. So we have the mean is 500 and the standard deviation is 60. We are to determine the probability that a random sample of size 16, n is equal to 16, determine the probability that a random sample of size 16 selected from this population will have a sample mean. So this is a probability concerned with the sample mean, which is represented by x bar, is less than 475. What I will first notice is that this is the sampling distribution of the entire population, not a sampling distribution of the sample mean. So if I'm going to get the probabilities concerned with the sample mean, I need to determine the shape of the sampling distribution of x bar. Well, if the population or the original population is a normally distributed population, then the sampling distribution of the sample mean will also have a normal distribution. Well, if it has a normal distribution, it must have a mean, that is the center value. So the mean of all possible sample means is always, based on the formula we established earlier, equal to exactly the population mean, which is 500. However, its standard error will be derived from the population standard deviation divided by the square root of the sample size. So with that said, I have the formula ready. I can compute. What is the population standard deviation? It was 60. I'll write that down. Divided by the square root of n. N is 16. And 60 divided by the square root of 16, which is 4, this will be equal to 15. So at this point, I have set up everything I need to compute the required probability. Now I will locate 475, 475, and I'm interested in the area below 475. Okay, so to find that area, I will go to StatCrunch. I will key in this respective these parameters of this distribution. So back here, I still have my interface for between, but this problem is not finding a probability between two values. So I need to adjust my interface back to the standard interface. Then I will set up my parameters. The mean is 500 and the standard deviation is 15. Please note that these values came from the mean value here and the standard error of the sampling distribution. Then I will locate, I want probabilities less than 475. So I will change this. This is already less than or equal to, and so I only need to change this to 475 and compute. So I have 0.047779. So 0.04779. And we proceed to question B. Determine the probability that a random sample of size n equals 64 from the population will have a sample mean greater than or equal to 515. Take note that when we wanted to get the sampling error here, we needed the sample size. So the sample error or the sampling error is a function of the population standard deviation. So that informs something I need to be careful or wary about here. If the sample size has changed, I should expect that the sampling error will also change, because this guy depends on the value of the population standard deviation and the sample size n. So I'm going to compute that just to note that. This will be population standard deviation was 60 earlier. However, the sample size is now the square root of 64. So this will be 60 divided by the square root of 64, which is 8. So 60 divided by 8, that is equal to 7.5. So the goal here is to find the probability that for this random sample of size 64, selected from the population, will have a sample mean x bar greater than or equal to 515. I know this is going to have a normal distribution since the parent population is normal. So I have the mean x bar equals 500 as usual. And the standard error is 7.5 this time. And I would like to find probability connected with 515. So I will locate 515, and I want the area above 515. So with that said, let's find that. So I need to adjust my parameters here, 507.5. I'll go back. This should be 7.5. And I am interested in going back to my notes. Probability greater than or equal to 515. So back here, I'm going to change this to greater than or equal to 515 and compute. This is 0.02275. So 0.02275. This is my answer. All right. With that said, there is something to note. Did you observe that when n was 16, the standard error was 15? However, if I multiply my sample size, I multiply it by 4, I will get 64. So when I multiply my sample size by 4, what happens to the standard error? What do you think? From 15 to 7.5. The standard error becomes what? Halved. So you should note one important property. In order to cut the standard error of the mean in half from 15 to 7.5, the sample size must be multiplied by 4 or must be quadrupled. This is very important to note because usually in applied research, our goal is usually to see how we can minimize errors. So this is worth noting.